So this is this lecture is on Dijkstra's algorithm. It's also known as the greedy algorithm. Single source, no negative, no negative values, no. So you can't use a negative value in there. So, and then you're going to generate what's known as the minimum spanning tree. Let's figure out so a GPS system can work this way. Let's check this out. What's the distance? So from A to A is 0. So there's no travel time in there. So I put coming from A, going to A is 0. Now from A to B it's 1. So I'm going to put a 1 there. I'm going to put coming down from A. A to C, I can't. There is no direct connection. It's infinity coming from A. A to D is also the same thing. Infinity, there is no direct link to A. A to E, there is 4. So coming from A, going to E, it's 4. A to F is 8. So this is 8 here, coming from A. A to G, it's infinity. That doesn't direct link, and likewise H. There is no direct link to H from A. Now, this is a directed graph, so all are connected. There is a 1, infinity, infinity, 4, 8, infinity, infinity. So the 1 happens to be the least cost, so I'm going to break that down. That's a B. Now, what is the cost from B to C? B to C. There is a 2 coming from 1 here, so that will be 2 plus 1, 3. That is better than infinity. See, that's 3 coming from B. Now, B to D, well, there is no direct connection. Leave it as infinity. B to D. B to E, there is no direct connection, but I had a 4, I'm going to leave the 4 there. B to F, there is a 6. 6 plus 1, that's 7, which is better than 8. So I put 7 there. Now B to G is 6 plus 1, that's a 7. B to G is 6 plus 1, that's a 7. So I put my 7 there, which is better than infinity. B to H, there is no direct link. I'm going to leave it there. So now this is my second pass. So I have 3, 4, 7, 7. Let's bring down the 3. And we are going to box it. That means we can't go back there. Can visit that city again, or that vertex again. Now C to D is a 1. 1 plus 3 is 4, which is better than infinity. Okay. Now C to E, there is no direct link, but I have a 4. I'm going to leave my 4 there. C to F, there is no direct link, but there is a 7, leave the 7 there, 7 coming from B. C to G, there is a 2, 2 plus 3, which is 5, so that's better than 7, so I'm going to put 5, because C to G is 2, 1 to B, B to C, A to B, B to C, and C to G. So that's where the 5 comes from. C to H, no direct link, so leave it as it is. Okay, I have 4, 4, 7, 5, infinity. These 4 are equivalent. I can take either one, so I'm going to take the first one, and I'm going to box it, and that's going to be D. Now, what is the distance from D to E? D, okay, let's look at D. To E, alright, there is no direct link. I'm going to leave my 4 there. Alright? How about D to F? D to F. There is also no direct link. I'm going to leave my 7 there, because that's better infinity, so 7 is better than infinity. D to G. D to G, which is 1. 1 plus 4, which is 5. It's the same. I'm just going to write down the from D, which is 5. It's okay. D to H. D to H is 4. 4 plus 4 is 8, which is better than infinity. That's it. See. So now I have 4, 7, 5, 8. I'm going to take the 4 down because that's the least. So 4 in. Now bring it to the left. So that's the edge now. I mean, that's the vertex. Now E to F. E to F. That's a 5. 5 plus 4. 5 plus 4, that's a 9. But I have a 7. So leave the 7 there. That's cheaper. Less amount. E to G. E to G, there is no direct link. I have a 5. I'm going to leave the 5 there. E to H, there is also no direct link. I'm going to leave it there. So this is what we have so far. I have 7, 5, and D. So I'm going to bring the 5 down because that's cheaper, or that's the cheapest. So I put my G there. Okay. Now what is G to F? G to F, there is a 1. G to F is 1. 1 plus 5 is 6. 6 is better than 7, so I'm going to put my G there. Okay, now G to H. G to H is also 1 plus 5, that's 6, which is better than 6. So that's it. That's a 6. Now I have 2 6's. I can take either one. So if I take this one down, so this is 6G. Okay, so I'm going to box it. That's F. Now all I have to do now is F to H. F to H, that's infinity. I can't get there. There's no direct connection, so I'm going to leave my 6G. Alright, so now I'm basically done. So I'm going to go down here and bring my 6G, and then if I box this, and this is H. That's it, I'm done. How do you compute the distance? We usually go backwards. So how did I get to H from G? Then if I go to G, that takes me to D, because that seems to be the cheapest one. If I go to D, that puts me into C, because C is 4. When I go to C, that puts me into B. When I go to B, that takes me to A. So this is my shortest path. So what's A to B? It's 1. What is B to C? That's a 2. C to D, that's a 1. D to G, that's a 1. G to H, that's a 1. So this would be 1 plus 2 plus 1 plus 1. 3, 4, 5, 6. So it's 6 units. That's the answer. So if you look back here, the shortest path, A to B, B to C, C to D, and D to G. So if you go into G, that's my shortest path, and then to H. And so if you add all these values, you're going to end up with 1, 2, 1, 1, 1. So that's 6. This is the whole idea of the Dijkstra's algorithm, and GPS systems can follow this for shortest path. Thank you.